In lesson 6.8, we dropped off yesterday after example 3A. I had started a little bit on 3B, and then, of course, the BenQ did a reboot overnight, and so my page is gone, so I haven't rewritten this one. Okay, as we look at the square root function, you guys tell me, what's that 3 doing?
Vertical stretch.
Okay, when you have a number multiplying out front, it's a vertical stretch or shrink. 3 is bigger than 1, so we're going to stretch it. What about this plus 2 under the radical? Okay, it's going to be left or right, and that's because it's under the radical, left or right, opposite the sign. So a plus 2 is going to take us left 2. Okay, whoever's doing that needs to stop. Thank you. Minus 4 is going to take us where? It's up or down because it's outside the radical. And you go the direction of the sign. So this graph is going to be going down 4. Now, the left 2, the down 4, those are a piece of cake, yes? What about this stretch of 3? What is a vertical stretch of 3 going to stretch? What were you going to say, Jocelyn?
I was just going to say how to do it.
Okay, go ahead.
You just multiply
And what is it I'm going to multiply by 3?
your x and y equals 0, 0, and 1, 1.
So he wants dice?
Yeah.
I'm guessing he wants this.
Like, I don't know. You just told me to come back.
If he wants dice, that's what he wants. Okay. So, vertical stretch. We are multiplying by 3. My question was, what are we multiplying by 3? The y values, right? It's not the x and the y. We're not going to multiply them both by 3. A vertical stretch, you're just multiplying your vertical numbers by 3. And which numbers take us vertical on the graph are the y values. So, now, yesterday, for a basic square root of x graph, right? On the front side of your notes, for a basic square root of x graph, we had the basic ordered pairs of 0, 0, 1, 1, 4, 2, and 9, 3. Those were the numbers we used for square roots because we can take the square roots. Because we are stretching by 3, we're going to multiply each of these y values by 3. And we're going to rewrite these. So these are 3 times y. So what's 0 times 3?
0.
1 times 3. 2 times 3?
6.
And 3 times 3?
9.
9. So, if you recall, the numbers we're going to graph, we use our original x's that didn't change and our new y values of 0, 3, 6, and 9. So we're going to use those two together. We're going to graph that set of ordered pairs. And then what am I going to do after I graph that set of ordered pairs?
Move left 2 down.
Okay, we're going to do our other movements. So I'm going to say, then move left 2, down 4. If you're super talented and tend to not get confused on these graphs, then do it all at once, right? I personally am going to keep it, I'm going to do 2 separate pieces here. Okay, so I'm not going to bother graphing 0, 0, 1, 1, 4, 2, and 9, 3, but I am going to graph 0, 0. I'm going to graph not 1, 1, but 1, 3. So right 1, up 3. I'm not going to graph 4, 2, but I'm going to graph 4, 6. Right 4, up 6. And I'm not going to graph 9, 3, but I'm going to graph 9, 9. Do you see what a stretch of 3 does to this thing?
Stretches it.
This stretches it way up, doesn't it? Okay. That 1/2 yesterday didn't shrink it very much, but this 3 stretches it way up.
Hey, can I see Hunter for just a quick second? Get him some here.
He's the invisible open desk right there.
All right.
Yep.
Carry on.
Okay. The red points represented that stretch of 3. What are we going to do with those dots if you haven't already done it? We're going to move them. So every dot I just did, 0, 0, I'm going to go left 2, down 4. And these blue dots are going to be my final answer. My 1, 3, I'm going to go left 2, down 4. Looks like I end up at -1, -1 there. Okay. 4, 6, I'm going to go left 2, down 4. Looks like there I end up at 2, 2. And then 9, 9, I'm going to go left 2, down 4. So what do we end up at 7, 5. And make sure you connect the right dots, yes? Okay. You're going to be able to do that on your own, right?
Yeah.
If I recall, I think Math Excel makes it relatively easy on you. But I do want you to be able to graph these by hand because that's what we're going to be doing come Chapter 6 test, okay? Okay, do we have what we need here? No, I don't know if it's this class or my other class. I'm getting ready to go to the next page, but do notice I did change our example 4 pieces. They give you some big pieces. However, do you even know what a cube root graph looks like? No. So it's kind of hard, in my opinion, to jump into A when we don't even know what a cube root graph looks like. So, I should have made that a little bit bigger. Oh well. Example A. We're just going to do the basic y equals cube root of x. Like, we need to know what a basic cube root of x graph looks like, because guess what? It is not at all like a square root graph. Okay? Now, if you don't know what a graph looks like, what do? We're going to work on creating an XY chart. Do we want to use the same values we use for our square root chart? No, because we picked 0. We ended up picking 0, 1, 4, and 9 because we could take the square root of those numbers. I want to pick numbers I can take the square root of. I changed the example. On 4A, I just scribbled it out and changed what it is. Sorry, I see a confused look back there of where are you at? I am just on the next example to scribble it out and change it. Okay, so what can we take the cube root of?
0.
Always 0, yes. What is the cube root of 0? 0.
Oh, wait, turn down there. 8.
Okay,
8, and then it is.
stop there. I don't want to do 8 yet.
You can do 6.
I can't do 6.
1, yeah.
How about 1? Okay, so 1. The cube root of 1 is 1. What is the next perfect cube? 8. Kind of like yesterday, someone said 6 for the square roots instead of 9, right? It's the same thing. Okay, but we're going to go 8 because the cube root of 8 is 2.
We're at negative 1.
Yeah.
Negative
If we go up from 8, your next option is 27.
Whoa.
Because the cube root of 27 is 3. You guys want to use 27?
No.
Okay. Now, I made myself obvious here, didn't I?
Yeah.
I left a gap because
Yeah, dude.
can you take the cube root of a negative?
Yeah.
Yes. So you need to use negatives. Yes, otherwise you're going to be missing half your graph. So, if we go the other way from 0, the cube root of negative 1. What's the cube root of negative 1? Negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. And the other cube root that we can do up here? Negative 8. The cube root of negative 8 is negative 2. You're not going to be doing nearly as much with cube roots. I'm going to focus more on the square root graphs. But as we talk cube roots, these are the numbers you need to be familiar with. Okay? So, let's graph it and see what it looks like. Negative 8, 2. I'm going to go left 8, down 2. Negative 1, negative 1. I'm going to go left 1, down 1. 0, 0. 1, 1. I'm going to go right 1, up 1. And 8, 2. Right 8, up 2. So, yes, it kind of looks like a line in the middle. It's not, though. You've got these two other outer pieces, right? Okay, with that in mind, when I draw this, that wasn't my best drawing, but you guys know the y equals x cubed graph that starts low, it kind of jogs at the center and goes up?
Oh, yeah.
This is the inverse of it, yes. Okay, so like earlier, the square root of x was part of an x squared graph, so it was part of a parabola, sideways. Well, y equals x cubed, I'm going to erase this here, but if you recall, y equals x cubed looks like this. What happens if you make it sideways? It's your y equals cube root of x. I'm not leaving that there, just drawing it in.
Is there anything else to the problem or just that?
Because that was just y equals cube root of x, that's it.
So this one would be the.
Right. Okay. Do you see how I created that xy chart, though? You know, I just thought about what things can I take the cube root of. Okay, b. I tried to make b not horrible. Y equals the cube root of x minus 5. So what are you thinking here?
Use the same numbers from the other graph and remove them down.
Okay. So it's going to be the cube root of x graph, so that same graph we just graphed. What does a minus 5 outside the radical do? It tells us to move the graph down 5. So, you tell me, do you need to graph your original dots or you just want to move them down 5? Okay, I mean if I graph my original dots, left 8 down 2, left 1 down 1, 0, 0, right 1 up 1, right 8 up 2. Graph the same dots as last time if you want, or don't, and then take each of those 5 dots and move them down 5. Now, I will say 0, 0 is the easiest one to move down 5 if you ask me. Because here's the deal. Once I have that center point, could I count from there?
Yeah.
You can't. Kind of like a parabola. A parabola, once we knew this vertex, we could always go over 1, up 1, and over 2, up 4. Same thing here. Once I know this center point, I can go over 1, up 1, and left 1, down 1. And from that center, over 8, down 2. And over 8, up 2. My red points are my final graph, in case you didn't figure that out.
You're going down 2, right? Over 8 down 2.
From your center point, yes. I hesitate whether I should draw do we have our points in the right spots?
Yeah.
Are we okay with that? I struggle to draw those graphs, even if I have points to go through, but.
I did too.
Questions there? Okay. One more section, and that is example 5. As we talk about example 5, it talks about rewriting a radical function. So these other functions we've seen, especially if you go up to the top of the page at example 4. Like if I go back here real quick, these functions up here are in great forms to graph them. And they're in great forms to, I know what's going on. I know as I look at this graph right here, I see a square root of x. I know there's a +2 that tells me to go left, there's a -4 that tells me to go down, there's a 3 that tells me to stretch. Okay, well, as we look at these ones down in example 5, this isn't square root of x and then some stuff. That's square root of 9x plus 18. So we're going to rewrite this so that we can get it and know there's a square root of x and we know what's happening to it. Is it being stretched? Is it being shrunk? Is it going left or right? Is it going up or down? So what do you notice about 9x and 18?
They're all under the radicals.
They're under the radical. What do they have in common? Do they both have a factor of 9 in them?
Yeah.
Okay, so what I'm going to do here, while under the radical, so I'm just going to rewrite this, but I'm going to factor my 9 out under the radical. So I wrote my square root. I'm going to put a 9, and then I'm going to put parentheses, right? 9 is my GCF if you want that vocabulary. So as I factor the 9 out, what goes in my parentheses? 9x divided by 9 is x plus 18 divided by 9 is 2. And so that's step 1 in rewriting it. Do we see an x now?
Yeah.
Yeah, now we see just a single x. I see a +2, which tells me something. But before we finish this and start talking about what transformations we see, what do you know about 9?
It's square.
Square root, so you just square root 3 and then it goes outside the radical.
That 9, because it is a factor now, I could not take the square root of 9 when it was just 9x and there was still that plus 18. But now that I have 9 times this x plus 2, I can. The square root of 9 is going to be 3, and that's going to go outside the square root. What is still under the square root?
And then there's just no.
Okay. So the first question was, how can you rewrite this using transformations? I just rewrote this so that I know what's being done. Okay, describe the graph. Okay, as we describe this graph, what is the basic shape of the graph?
Half of a U.
Okay, it's the half of, but so what equation is that based on? The base equation is square root of x, right? So this is the graph of y equals square root of x. And what are we going to do with that y equals square root of x graph?
We're gonna stretch it by 3.
It's going to have a vertical stretch by a factor of 3,
It's going to go
Go to the left.
or left.
and it's going to translate left to. That's me describing the graph. I'm going to put that in words, but that's me describing the graph. Now I am going to start and say, what graph is it that we are stretching and translating? And it is the graph of y equals square root of x. I'm naming what graph we're doing all this to. Stretched vertically by a factor of 3. So stretched vertically by a factor of 3, and not just moved left 2, but I'm going to use my fancy algebra word of translated left 2 units. That's a good full description. I stated what graph it is that I'm moving and stretching. I stated that it's not just a stretch, but it's a vertical stretch. And it's a vertical stretch by a factor of 3. And I didn't just say I moved left or moved left 2. I translated left 2 units. Not that I'm totally against moved or shifted, but the good algebra word there is translated.
On your test, would you care if we used like moved or translated?
I would be okay with things like moved, translated, shifted. What I do kind of dislike is when people just say left 2. Like, give me a verb in there. I know it's not English class, but
Do you also want us to do like label the graph also in ours, like on the test? Like the graph of y equals x?
I would ask that, yes. Yeah. Okay, so that all right there is my describe the graph. And the reason we're describing the graph is because when you look down at the next example, is it still a square root of x? No. It's a cube root of x, isn't it? Okay. I don't see cube root of just x yet, though. What do you see happening under that radical?
8x plus 32.
And what do we know about 8x plus 32? What do they have in common? A GCF of 8. And is 8 helpful to us? What world are we in here? We're talking cube roots, right? Can you take the cube root of 8? Yeah, so 8 is a good thing. It wouldn't be a good thing for square roots, but it is for cube roots. So I'm going to rewrite this. The cube root, I'm going to factor my 8 out, so it's going to be 8. And then when I factor that GCF of 8 out, it's x plus 32 divided by 8 is 4. And then you still have a minus 2 outside your radical. Good news here. The cube root of 8 is 2. So I'm going to rewrite this as 2 times the cube root of x plus 4 minus 2. Look for that GCF under the radical. And once you see that GCF under the radical, it's pretty easy to figure out from there because it's designed so that GCF is a perfect cube in this case or a perfect square in the last case. Okay, so what graph am I using here? This is the graph of y equals the cube root of x, isn't it? You got all the pieces?
Stretch vertically by a factor of 2 and translated left 2 down 2. Left 4 down 2.
Okay. The 2 out front is our stretch. And again, it's a stretch because it's bigger than 2, right? The plus 4 under the radical is left to right, so that's left 4. The minus 2 outside the radical is down 2. Okay, I'm going to write it out. The graph of y equals cube root of x stretched vertically by a factor of 2 and I'm going to use my word translated left 4 and down to units. Sorry, that is not very neat at all, but I did read it out loud as I was writing it, so hopefully you kept up there. Okay. Questions? Well, you have this crazy thing. I haven't had it in a while.
Work time.
Work time. Your homework, in case you are wildly unaware for some crazy reason, is lesson 6.8 in Math Excel. And if you are wildly unaware, I don't know where you've been, but